Imagine a line of people passing buckets of water, one after another. That's kind of what a shift register does with digital information. Shift registers are like electronic containers inside computers and other digital devices. They store and move bits, the zeros and ones that make up digital information. Why are they important? Because they help manage the flow of data in a controlled way. Think of traffic lights. Shift registers help sequence the lights, making sure things move smoothly. Without them, our digital world would be a chaotic mess. Shift registers come in different flavors, each with its own way of handling data. Let's explore these different types and see how they work their magic in the real world. Get ready for some fun facts along the way. Imagine a conveyor belt at the airport baggage claim. Bags are placed on one end and travel along the belt until they reach the other end. This is similar to how a serial in, serial out SISO shift register works. Data bits, our bags, enter one bit at a time in a single line, like being placed on the conveyor belt. Each clock pulse, which is like a signal telling the belt to move, shifts the bits one position down the line. The data bits come out in the same order they entered, just like at baggage claim. SISO shift registers have some cool uses. Ever heard a delayed version of your voice on a loudspeaker? That's often a SISO shift register at work, creating an echo effect. They're also used in communication systems to recover data that might have been distorted during transmission. Fun fact. The first shift registers were used in the 1940s in early computers. Back then, they were made with bulky vacuum tubes, not like the tiny microchips we have today. Now imagine a vending machine. You put coins in one at a time, serial input, but when you've paid enough, all the snacks in the row become available at once, parallel output. That's the basic idea behind a serial in, parallel out, SIPO shift register. Data enters one bit at a time, like coins in the vending machine. These bits are shifted through the register with each clock pulse. Once the register is full, all the stored bits are available simultaneously at separate outputs. Practical applications of SIPO shift registers, turning serial data parallel. SIPO shift registers are super useful for converting data from serial format, one bit after another, to parallel format, multiple bits at once. This is helpful in things like digital to analog converters or DACs used in audio systems. They're also found in some types of displays, taking serial data and converting it to light up multiple pixels simultaneously. Pretty neat, right? Parallel in, serial out, PSO, shift registers, gathering data for a single file line. Let's picture a group of people trying to board a crowded bus. They start in a jumbled crowd, but then they form a single line to get on the bus in an orderly fashion. This is similar to how a parallel in, serial out, PSO, shift register operates. It takes in data bits simultaneously from multiple inputs. Then with each clock pulse, it shifts these bits one by one out of a single output, like passengers boarding the bus in a single file line. PSO shift registers in action, from keyboards to communication. PSO shift registers are commonly used in keyboards. When you press a key, it sends a parallel signal representing that character. The PSO shift register then sends this data serially to the computer. They are also used in serial communication systems, where data from multiple sources needs to be transmitted over a single line, like sending text messages from your phone. Parallel in, parallel out, PIPO, shift registers, data transformation stations. Imagine a busy train station. Trains arrive with passengers in different cars. Inside the station, passengers disembark and rearrange themselves onto different trains leaving for various destinations. This is analogous to how a parallel in, parallel out, PIPO shift register functions. It takes in data bits in parallel form, stores them temporarily, and then outputs them in a modified parallel form. This might involve rearranging the order of bits or performing simple logic operations on them. The enduring power of shift registers. Shaping the digital landscape. Shift registers in their various forms are essential components in countless digital devices we use every day. From controlling the timing of traffic lights to enabling communication in our smartphones, these seemingly simple devices play a crucial role in shaping our modern digital world. As technology continues to advance, shift registers will undoubtedly continue to evolve and find new applications, further solidifying their place as unsung heroes of the digital age.